This video is going to be talking about functions of several variables. So as an example, number one, suppose a company sells a bike with a price demand equation of P is equal to 900 minus 17Q. Suppose the company sells 10 bikes, how much should they charge? So P is equal to 900 minus 17, and then they're selling 10 bikes, so 10 in for Q. And that gets that they should charge $730 for these bikes. Now, suppose the company also sells another bike with a different price demand equation of P is equal to 5,200 minus 4Q. If they sell 5 of these bicycles, then the price should be P equals to 5,200 minus 4 times 5. And that is 5,180 for 5,180. To reduce confusion, different names should be given to the variables in the different situations. So suppose that let's call Q1 the number of low-end bicycles sold, P1 the price of the low-end bicycles, Q2 is the number of high-end bicycles sold, and P2 is the price of high-end bicycles. The company could work with the individual price demand equations for the different bikes, but there could be a relationship between the selling of the two bikes. It could be that if one sells more of the low-end bicycles, then could be less of the high-end bicycles sold, and vice versa. So the price demand equation for the two bicycles could be P1 is equal to 900 minus 17Q1 plus Q2, and P2 could be 5,200 minus 4Q2 plus 2Q1. If you want to sell 10 low-end bicycles and 5 high-end bicycles, how much should the two types of bicycles be sold for? So P1 would equal 900 minus 17 times Q1, and Q1 is 10 because Q1 is the low-end bicycles, plus Q2, so plus 5 because 5 is the high-end bicycles. So that gets that the low-end bicycles should be $735. P2 is equal to 5,200 minus 4 times 5, Q2, plus 2 times 10, Q1. And that is equal to 5,200. Suppose the cost function of the two bikes to shops to buy, store, and sell the two types of bicycles is given in a month as C is equal to of Q1, Q2 is equal to 4,100 plus 56 Q1, 560 Q1 plus 4,200 Q2. What is the cost in a month to buy, store, and sell 10 of the low end and 5 of the high end bicycles? So C of 10 comma 5 would be the 4,000 plus 560 times the number of low end, which is 10, plus 4,200 times the number of high end, which is 5, is equal to 30,600 per month, dollars per month. The revenue function for selling the two types of bikes would be R of Q1, Q2 equals P1, Q1 plus P2, Q2. Remember, the price demand equations are P1 times 9,200 minus 17Q1 plus Q2, and P2 is equal to 5,200 minus 4Q2 plus 2Q1. So the revenue for selling the two types of bikes is equal to R of Q1, Q2 is going to equal P1, which is 900 minus 17Q1 plus Q2 times Q1 plus P2, which is 5,200, minus 4Q2 plus 2Q1 times Q2. Looking at the formula. So that's equal to 900 Q1 plus 5,200 Q2 minus 17 Q1 squared minus 4 Q2 squared plus 3 Q1 Q times Q2. The revenue from selling 10 low-end and 5 high-end bicycles in a month would be R of 10, 5 is 900 times 10 plus 5,200 times 5 minus 17 times 10 squared minus 4 times 5 squared plus 3 times 10 times 5. And that comes out to be $33,350 per month. The profit is easiest to find by remembering that profit is equal to revenue minus cost. So the profit in the month of selling 10 low-end and 5 high-end would be P of 10, 5 is equal to the revenue at 10, 5 minus the cost at 10, 5, which is 33,350 minus 30,600, which is going to equal $2,570 per month. To increase the profit, the bicycle shop could either sell more of the two types of bicycles, or add more types of bicycles, or other merchandise to sell. This is one reason to use the subscript so that one can have as many variables as one has merchandise. Another example of a business application is the Cobb-Douglas function. The general Cobb-Douglas function looks like f of xy is equal to a times L to the alpha times k to the beta, where L is utilization of labor and k is utilization of capital. The book has a link to the site to learn more about this function. The constants a, alpha, and beta depend on the situation that is being modeled with this function. See the textbook for how to graph two variable functions of the form z is equal to a function of x, y, where x and y are the independent variables and z is the dependent variables. In the Cobb function, this actually should be f of L and k instead of x and y.